Hi guys, today we are going to learn about writing equations of lines that are parallel and perpendicular to other lines. So we need to first get a few characteristics of what makes lines parallel and what makes lines perpendicular in terms of their slope in algebra. So we're going to start with parallel lines. Parallel lines are lines that basically go in the same direction. They never intersect is their definition. So in order to make lines parallel, I'm going to draw an example of something that has a slope of 2. So we'll start it here. We can start it anywhere we want. I'm going to go up 2 over 1. And this is just a sample line. We can go backwards 2, down 2, and to the left 1. So here's a line. If I want to draw something that is going to be parallel to that, it basically needs to go up in the same direction. So just to sketch it, it should look something like this, so that they never intersect. In algebra, because these two lines are slanted at the same rate, basically, their steepness is the same. That means their slopes in algebra are the same. So parallel lines, to get this precisely parallel, if I pick any other point to start with, let's say I had to start at this point right here. Maybe the direction said it has to contain that point -2, -2. In order to make a line that is parallel to this, the slope must also be 2. So I would start at this point right here and go up 2 over 1 like that. So I'm just going to continue that a few more times, and now we've got ourselves a line that's parallel. So the important thing that you know is that parallel lines are lines that have the same slope. Notice the y-intercept is irrelevant. We don't have to have the y-intercept, and in fact we can't. If we had the same y-intercept, then that means this line would just be exactly the same, because it would have the same slope and the same y-intercept. So the y-intercepts should be different, but their slopes are going to be the same. That's all that's important. If their slopes are the same, the lines are parallel. Now, perpendicular is a little bit trickier. Most of us know that perpendicular lines are lines that cross at a right angle. So the simplest example of perpendicular lines are like a vertical and a horizontal line. It's easy to see that they cross at a right angle. It's a little bit harder when we take that example of a line that has a slope of 2. There is a relationship between the slopes of perpendicular lines, but it's not quite as easy to see as it was for parallel lines. So let's try a couple of different things first, and then I'll tell you exactly what the relationship is. So since this line has a slope of 2, some things you may try to guess are, well, maybe we need to have kind of the opposite. Maybe we need to have a slope that's -2, because a -2, any negative slope would point like in this direction. So let's try, see if a -2 slope would be perpendicular. So I'll pick a starting point, maybe right here. And instead of going up 2 over 1, we're going to do a negative, so I'll go down 2 over 1. And then I can go backwards a bit, get a few points here. And let's see if this looks perpendicular. Well, it crosses, it's not parallel, but this is not a right angle. So that's not working. We're not going to get a slope of just making it negative doesn't seem to make the lines perpendicular. So the other thing that we might want to try is, let's try 1/2. So instead of 2, let's look at the reciprocal. Maybe a slope of, a slope of 1/2 would work. So I'll pick a point to start with to draw another line and see, I'll pick this point, that way we know we're crisscrossing with that line. And if I go up 1 over 2 to have a slope of 1/2, what does that look like? Because we need it to be not quite as steep, maybe. Oops, used the wrong point there. So here's a line that has a slope of 1/2. Still not working. This is still not a right angle. But compared to the other one, it looks like maybe if we used a combination of those two ideas, maybe we'll get something that works. So we're going to draw a line that has a slope of -1/2. So we'll try that. Maybe if we flip it and make it negative. So I'm going to start with one of these points that I have. I'm going to start with this point right here. And I'm going to try to draw a line from here that has a slope of -1/2. What that means is I go down 1 over 2. Down 1 to the right 2. And I can also go up 1 and to the left 2. And keep making points that way. Let's see if this looks a little bit more like a perpendicular line. And if you look really closely, it's a sketch, so it's not perfect. This does look like a right angle. So that actually is the way we find slopes of perpendicular lines. The slopes of lines that are perpendicular have slopes that are the opposite, meaning positive, one negative, and the reciprocal. So we call that the opposite reciprocal. So in order to figure out if lines are perpendicular, their slopes should be the opposite sign and perpendicular. And I'm sorry, the reciprocal to be perpendicular. So we're going to do some examples and we're going to compare different lines. Let's look at another example on a graph first. So if I take any old line, I'm just going to start it here, and I'm going to use a slope of 2 over 3, positive 2 over 3. That means from this point I go up 2 over 3, up 2 over 3, or I can go backwards, down 2 over 3. That means in order to draw a line that is perpendicular, I should use something that has a slope of negative, because they have to be the opposite, and instead of 2 over 3, 3 over 2. So I'm going to pick any old point to start with. We'll just start right here. And we'll go down 3 over 2. Or we can go up 3, left 2. Up 3 to the left 2. And here's that line. So the slope of 2/3 is that one. The slope of -3 over 2 is this one. And if you look at it, it does look like it makes a right angle. It doesn't matter where I start the other line to be perpendicular. So in other words, the y-intercept and the other points are irrelevant. As long as it has a slope of -3 over 2, it'll meet at a right angle. It'll be perpendicular to that line. So if I take this line that has a slope of -3 over 2, and instead of starting it at this point, let's say I move it down and started it at the origin, 0, 0. It's still making a right angle where it crosses. So the y-intercept, let's say I make the y-intercept -2. Doesn't matter. It still makes a right angle. So all we're concerned with to make lines parallel or perpendicular, or to tell if lines are parallel or perpendicular, is that their slopes are opposite and reciprocals. So let's look at some actual example problems. This was all to explain the reasoning why the slopes have to be the way they are. For parallel, they have to be the same. And for perpendicular, they have to be opposite reciprocals. Next, we'll actually do some problems that you'll run across. So just to recap, this is what we need to take away from what we just learned. This should be written in your notes, and you need to have this memorized. Parallel lines have slopes that are the same. Perpendicular lines have slopes that are opposite reciprocals. So if need be, pause this, write this down. This is the takeaways from this lesson. So here's some examples of things you might have to do. You might have to state the slope of a line that would be parallel or perpendicular to a, whoops, and that is actually supposed to say perpendicular. There we go. So if we have this line, y equals -2x minus 5, if we were to write the equation of a line that's parallel, or graph a line parallel to that, the slope would need to be the same. So in this case, the slope would need to be -2. Same line, if we wanted a line that was perpendicular to either graph or write an equation of, we would need a slope that is the opposite reciprocal of -2. Since we can assume -2, the whole number, is -2 over 1, its reciprocal would be 1 over 2. And we want it to be the opposite, so since that one's negative, the line that would be perpendicular would have to be positive. So for a perpendicular line, if your slope were -2, the slope of the perpendicular line would be positive 1 over 2. Opposite reciprocal. Let's look at another one. So in this case, the equation is y equals 2/3 x minus 9. So my slope is 2/3 of this line. So the slope of a line parallel, that's the simpler one, has to be the same. So it's 2/3. The slope of a line that's perpendicular to 2/3 is, we need the opposite, so it's going to be negative since that one was positive, and the reciprocal, so 3 over 2. Negative 3 over 2 would be the slope of a perpendicular line. One more. Now in this case, I can't just look at this equation and see what my slope is because it's not in slope-intercept form. Slope-intercept form has y isolated. It's y equals x plus b. If it's not written in that form for you, you have to convert it to slope-intercept form. Basically, you isolate y. So I'm going to take this equation, move it up here, and isolate y. To do that, I'm going to subtract 2x from both sides to move that 2x over. I have -5y on one side. And then I'm going to write the 2x first. -2x, and 15 is positive, so plus 15. Then I'm going to divide everything by -5. So once I'm done with that, what I have is that my line is actually y equals, that's a negative over a negative, so positive 2 over 5x minus 3. 15 divided by -5 is -3. Now that I have it in slope-intercept form, I can tell what my slope is. My slope of this particular line is 2/5. So the line that would be parallel to it should be the same, 2/5. Now for perpendicular, again, I have the same line, so I don't have to recalculate this one. The slope of this line is 2/5. So to get a perpendicular line, I need to take the opposite reciprocal, -5 over 2. So that's just how do you identify the slope of a parallel or a perpendicular line. The other thing we might have to do is just determine if lines are parallel or perpendicular or not. And to do that, we can just look at their slopes. It's in slope-intercept form. So we'll do a few examples like this. These are two separate lines. I don't need to graph them or anything like that. The slope of this first line is -8, and the slope of this second line is +8. In this case, they are neither parallel nor perpendicular. To be parallel, they'd have to be identical, both -8 or both +8. To be perpendicular, if the first one were -8, the second one would have to be +1 over 8. So it would have to be the reciprocal. That's what we're missing. So in this case, just having a +8 and a -8, that's not parallel or perpendicular. Here's another example. I can tell the top one what my slope is, and you should always write the slope down. The slope's -4 for the first one. For the other one, it's not in slope-intercept form because y is not by itself. I need to move over this 4x to get y by itself. So when I write it in slope-intercept form, I can see that my slope of this second line is also -4. Since both slopes are -4, when the slopes are the same, that means the lines are parallel. But you can't assume you know unless you have y isolated and it's in slope-intercept form. Then you can just pick out the slope, and if they're the same, it's parallel. All right, here's another example. We need to get y by itself to know what these slopes are, to know if we have parallel or perpendicular lines. So in this one, I need to divide everything by 2 to get y equals 3x plus 5 over 2. So in this first example, the first line, I have a slope that's +3. I need to do something with the other one too. I need to isolate y. So to do that, I'm going to take away the x first. That gives me a -x plus 4. Or 4 minus x would be okay too. Then I need to divide everything by 3. So then what I have is y equals, and you can pretend there's an invisible 1 in front of this x. The slope right here is negative 1 over 3 when you divide 1 by 3. And you can write the x this way. So you can write it like this, whoops, plus. It doesn't matter that the y-intercepts here are fractions. We're not asking you to graph this or anything like that. The only thing we're worried about is that slope. So the slope of this one, once you've determined this, you can see that the slope is negative 1 over 3. So since my slope of my first line is 3, and my slope of my second line is negative 1 over 3, those are opposite reciprocals, so the lines are perpendicular because the slopes are opposite and reciprocals. Okay, the last thing that we're going to work on today, now that we know how to identify parallel and perpendicular lines, is we're going to have to write equations of parallel and perpendicular lines. So, this is an example of a type of question you'll have to do. Write the equation of a line that's parallel to this line and contains the point 1, 6. When you start doing these problems, I would suggest you draw a line over that and put just the information you need to write the equation of a line. To write the equation of a line, you always need the slope, so you have to figure out what your slope is supposed to be. And you always need at least 1 point. It would be great if it's the y-intercept, so that you can put it in slope-intercept form, but at least 1 point, any point on that line. So the line that I'm trying to write, it's not this line. I've already got the equation of this line. I need to write an equation that's parallel to this line. So since this line has a slope of 3, I need to write a line that also has a slope of 3, because a parallel line would have the same slope as that one. I don't need anything else with this line, so you can cross it out once you got the slope from it. We don't want to look at it and accidentally use it for something else later. We don't need that line anymore, except to know that our slope is 3. The line I'm supposed to write is also supposed to contain this point 1, 6. So I'm going to put that again, rewrite it with my information. Now this should be review. We should all know how to write the equation of a line if we have the slope and a point. I'm going to do it by putting it in point slope form first. Point slope form says you do y minus, and you plug in your y of your point, equals slope, x minus, and then you plug in the x of the point you're given. And then you can solve for y to put it in the proper slope-intercept form. Most of the time, you do need to put it in slope-intercept form, and what that means is you isolate y by distributing on the right side, and then moving this number over right here by adding 6. And that's the equation of the line. So other than this step right here, getting your slope for your parallel or perpendicular line, everything else is writing an equation of a line like we've done before, where you just write the equation given a point and a slope. So let's try another one. All right, this one's a perpendicular one, and it's the last example. We're going to write the equation of a line that's perpendicular to this line, and it contains the point -3, 5. Well, before I can even do that, what we had to do first was figure out what the slope was of the other line. It was in slope-intercept form. This is not in slope-intercept form right now. Just like all the other examples, I need this equation written in slope-intercept form so I can see what the slope of this line is. I'm going to do that by dividing everything by 4, and then y will be isolated, so it'll be in slope-intercept form. This -6 over 4 can be simplified. I'll simplify it in another step. 8 over 4 is 2. 6 over 4 is -3 over 2. So this is the equation. This is not my answer to the line. All I've done is taken this one they gave me and written it in slope-intercept form. So I'm not done by far. The slope of this line is -3 over 2. Now I'm going to go ahead and draw that line like I told you to. And I'm going to write the information that I need, my slope and my point for the line I am trying to write. I'm trying to write an equation of a line that is perpendicular to this line. Perpendicular to something that has a slope of -3/2. So the perpendicular, that's the symbol for perpendicular, by the way, the slope of a perpendicular line should be the opposite reciprocal. So my line I'm going to write an equation for is going to have a slope of +2/3. That's the opposite reciprocal of -3/2. The point that my line is supposed to contain is -3, given right there. That's the only information I need. I no longer need any of this. It might be wise to kind of scratch it out so you don't accidentally use it. All we need to do is use these two pieces of information to write our equation now, just like we did before. I'm going to put it in point-slope form first, since a point and a slope, that's the more logical one to use. So point-slope form says y minus, put your y value in, your slope, and in parentheses, x minus, plug in your x value. So that ends up being minus a -3, which is +3. In point slope form, remember, you're always plugging it in kind of with the opposite sign that you would normally expect. And now all we have to do is isolate y. So I'm going to distribute 2/3 to everything. So we'll have 2/3 x plus 2/3 times 3 is just 2. If you need to do that off to the side, you can, but those 3's cancel when you do 2/3 times 3/1. Add 5 to get y completely itself again. Plus 7. That's the equation of my line. That's what I needed to do. From there, we could do other things with it if we needed to graph it, if we needed to figure out the x-intercept, y-intercept. We have to write our equation first, and then we could answer other questions about that line. But that's it. That's how you identify and write equations for lines that are parallel or perpendicular.